So today we're gonna deal with exponents. Exponents, I think it's an area where maybe I'll take 2 weeks to explain because it's math 9 and math 10 together. So I want to do them, combine them, but we're gonna start slow so people don't get lost. Yeah. So when you're doing exponents, you have to remember the exponent rules. Okay. So for some of you who don't know what exponents are, and most of you would know what exponents are, but just in case some of us forgot what exponents are. So, if I write 3 to the power of 2 right here, it just means 3 to the power of 2. It doesn't mean 3 times 2. It means 3 times 3. Okay. Or there's a button in your calculator. If you go 3 to the power of 2 on your calculator, it will give you 9. Yeah. So 2 to the power of 3, it just means 2 times 2 times 2. 3 times, and that will give you 8. And where 3 squared will give you 9 because it's 3 times 3. Yeah, so this is what exponents are. Yeah. Today we'll be dealing with negative exponents as well. And we'll go more into negative exponents as we get deeper into grade 10. But if I have 2 to the power of negative 2, what we do, we cannot work with negative exponents. We cannot just say this is 2 times 2 twice, because this is definitely different from this. This does not equal this. So this will be 2 times 2 twice. But what's this when it's negative exponent? When it's negative exponent, so always know if we write a 3 right by itself right here, just know the 3 is over 1, but we don't write that 1 in n. Okay, so this is 3 over 1. Any number that exists, it's always over 1. So you could look at it as a fraction. So this 2 to the negative 2, also think about it as over 1. So what we need to do, we make the exponent positive. So to make the exponent positive, we bring this 2 to the negative 2 to the bottom of the fraction. And if we bring this to the bottom of fraction, we have 1 left on top. And this will become 2 squared right here. And this then will be 1 over 2 times 2, which is 1/4. Okay. So this may be just to tell you once we hit negative exponents what it means. So the rules of exponents, and that's what you should take a picture of right here. And I'm just going to erase the rest. So I'm just going to erase this, but this here, take a picture, write it down, whatever works for you. All right. And I'll go over them. So if you're multiplying 2 variables to the exponents, okay, x to the power of a, x to the power of b, that just means when you multiply variables, you add their exponents. So this becomes x to the power of a plus b. Okay, what does that mean when we deal in terms of numbers? Okay, in terms of numbers, we have 2 to the 2 times 2 to the 3. All you need to do is just go 2 to the power of 5, because when you're multiplying, we add the exponent. So what we call the 2's here, we call them the base. And this 2 on top, we call it the exponent. Okay, so when we multiply bases, we add their exponents. Very important to remember that. And then 2 to the power of 5, it just means 2 times 2 times 2, 5 times, and that will give you 60. No, that will give you 32. You could do it in your head. Like 2 times 2 is 4, and then times 2 is 8, and times 2 is, that's the 4, 2, 16, and times 2, the 52, it gives you 32. All right. And then if we're dividing bases, the bases here are x and the exponents are a and b. We minus the exponents, okay? So what does that mean? It means in terms of numbers, if we have 3 to the 9 divided by 3 to the 7, then it just becomes 3. You minus the exponents, you get 3 squared, which is 9. Okay, now this is this rule right here. And then I'm just going to erase these 2 right here. Also, the next rule to this is if we have the base to the power of a, and that's inside the brackets, and we have another exponent is m. In this case, you multiply the exponents together, so it becomes x to the power of am. So in case we have negative 2 to the power of 2, all to the power of 3, then the first thing, we multiply the exponents together right here. So that becomes -2 to the power of 6. Okay. So that's this rule. Now, how we solve this? Okay. Now, another thing I want you to remember, everybody, is that when you have a negative number inside the brackets and you have an exponent outside of the brackets to the power of an even number, if this is even, then what happens, the negative becomes positive. And 2 to the power of 6 just gives you 64. But if this was odd, like if this was -3 cubed, for instance, then if the exponent is odd, the answer will be negative, and 3 cubed, which is 3 times 3 times 3, which is 27. Okay. So, negative times negative is positive, times the third negative, positive times negative is negative. That's how it works, but you could just memorize it that if it's an even exponent outside of the brackets, the negative becomes positive. And if it's an odd number outside of the brackets there as an exponent, then the answer is negative. Now, if you have a question, I'm looking at the chat every now and then, just say, can you explain that again? And then I'll go. So instead of asking you if you understand, I just want you to write something in here, and then I'll go over things again. Yeah. So here's another rule right here that I explained to you earlier. I said if you have x to the power of -a, we don't like negative exponents. Hate negative exponents. Negative exponents. So we don't want negative exponents. Therefore, what we do, we want to change that negative exponent to positive. To be able to do that, as I said, everything that you write, it has a 1 underneath. So what do? You bring that to the bottom where the 1 is, and when this comes to the bottom, you still have a 1 left on top, and then the exponent becomes positive. So now it's x to the power of a on the bottom. So x to the -a just becomes 1 over x to the a. And I think I explained that to you earlier. So I said if you have 3 to the -2, that's just becomes 1 over 3 to the 2. And that gives me 1 over 9. Then you could do it, with the same thing, if you have x on the bottom, but the exponent is negative. So now, if it's on the bottom, and exponent negative, it could just jump to the top and the exponent becomes positive. Like this, the exponent is negative, and that this is on top of the fraction, because everything is a fraction, has a 1 underneath. It goes to the bottom for the exponent to become positive. With the same token, if the variable is on the bottom that has a negative exponent, will just jump to the top where the 1 is, and the exponent becomes positive. So if we have 1 over 2 to the -3, this basically the 2 to the -3 goes to the top. So it becomes 2 to the 3. It gets multiplied into the 1, but anything multiplied by 1 just itself. And then we have 1 underneath. We don't have to write that. So 2 to the 3, which gives me 8. Yeah. Also, if we have x over y to the power of -a, since the exponent is negative, and it's for everything here, when it's in brackets and it's a fraction, just remember that it belongs to the x and it belongs to the y. All right. So basically, if I have a 3x, and this is maybe squared to the power of 2, this exponent here outside the brackets has to get multiplied in both exponents, and the one inside, both the exponents inside. Now, lots of people, and I want you to focus on this because that's a common mistake a lot of students make. Yeah. So they go, hey, I know how to do this. I have to multiply the exponent inside. This becomes 6x to the 4. I say that's wrong. We said you multiply the exponents. This is not an exponent, is it? This is a base. What's the exponent of this base? Can anybody tell me? What exponent does the 3 have? So I need you to write it down. Is everybody awake? Give me an answer. Good to know you're awake. Okay, so Nigar, you gotta stay awake, eh? Like you guys have like anything you're doing, anything on the other side, stay. This lesson is one of the most important lessons you do in math. It's like fractions. You have to understand your exponents because everything evolves around exponents. So stay alert. The question was, if I have x to the 3, y to the 5, and I have an exponent outside, as we said, when we have an exponent outside, we multiply it into the exponents inside. So we multiply the 2 into the 3 and a 2 into the 5. That becomes x to the 6, y to the 10. Phoebe, you're there? Phoebe. So just let me know.
Hello.
Okay, how you doing?
I'm well. How are you?
Good. So now I'm asking everybody to answer. So I said here, the common mistake when we have something like this, students go 2 times 3 is 6, and then this becomes x to the 4. And I said this is wrong because the rule is you multiply the m here into the exponent inside. This exponent gets multiplied into the exponent inside. So now the 3, what kind of exponent does the 3 have? What exponent does the 3 have? When we write a number by itself, it has an exponent. Every number that you see, like you count from 1, 2, 3, 4, 5, every number here has an exponent of 1 that we don't write, because when it's 1, we don't write it. So when we say that the exponent gets multiplied, the exponent outside of the brackets gets multiplied into the exponent inside the brackets, make sure you know that's a 1. You don't multiply the 2 into the 3. That's a base. You don't multiply the exponent into the base. You multiply the exponent into the exponent. So that gives me 3 squared x to the 4. And then you could answer this as 9x to the 4 because 3 squared is 3 times 3, which is 9x to the 4. Okay, we'll move on. Please pay attention. This stuff, it's what I'm teaching you this year is like this is it's grade 9 and 10, but it's more geared to get you prepared for the higher math for 11 and 12. So you understand how these things work, because these you're gonna get hit all the time with this kind of things. So hold on a second. I think I erased something that I still needed up there. When did I erase that? I erased it earlier. Yeah. So x over y to the power of negative a. All you need to do is just flip this, and then it becomes y over x to the power of positive a. So the x over y, just go y over x. This goes to the bottom, this goes to the top, and then the exponent becomes positive. So if we have, for example, 2 over 3 to the negative 1. All you need to do is just make that 3 over 2 instead, and then that becomes to the power of 1. And anything to the power of 1, we just write it as 3 over 2. If this was negative 2, then this will become 3 squared, okay? 3 over 2 squared, sorry. And what does 3 over 2 squared equal here? Even though it's a fraction, you don't just square the top, you also square the bottom too. So this becomes 3 squared over 2 squared, which is 9 over 4. Then I had another rule there that this one I'm not going to talk about right now, okay? So leave this alone. Write it down though. Like if you're writing the rules down or taking a picture, just make sure it's included. But one of the rules that I want to explain to you that if you have ax to the power of 0, anything to the power of 0 is always 1. It doesn't matter how much things you have here. You could have like 3x squared, y to the 9, z to the 1000. If you close that and put a 0 there, then the whole thing becomes 1. Everything to the power of 0 equals 1. Yeah. So these are the rules that I want you to know before we go on into the other stuff. And we're going to start tackling some of this stuff. Yeah. So this here, you could go either 3 to the 5, and then you should be able to use your calculator. You're allowed to use the calculator. I don't expect you to go 3 times 3 is 29, times 3 is 27, times 3 is 81. and times 3 is 243. I don't expect it there. So just go to your calculator. Everybody calculator is different. You have a power button. If you don't know how to use the power button, send me a picture and I'll show you how to use of your calculator, and I'll tell you how to use it. Okay, but use the power button to do this. Also, some people, they choose to change this to 9 right away and then this to 27, and they do it that way as well. Either or, you could do it that way, but because we are working with exponents, we want to do this first, and then you could just go to your calculator. You go 3. Either you have an arrow that faces up to the power of 5, and it gives you 243. Okay, did I say 324? I said 243, didn't I? Or some of you will have, you press N3 and then you see a button says y to the power of x. That's your exponent button. But get familiarized, because you need that for exponents. Okay. Number 2, we multiply and we just add the exponent. So what I want you to do now, I want you to take a few minutes to do this yourselves. Okay, so I'm just going to give you 5 minutes after I explained what I explained. I want to see how far you go with this, and then after 5 minutes I'll go over them. It's just everybody list their answers right here. Okay, so again, these ones are easy as we wrote them really fast, but here, when it's a fraction, you're dividing, you minus the exponents, you get the whole thing to the power of 2. Remember, that's 3 squared and 4 squared, so 9/16. Now here, when you have an exponent outside of the brackets, you multiply it into the exponent inside the brackets, so that's -2 to the power of 6. And since the exponent is negative, we said, since the exponent is even and it's a negative number inside the brackets, this will give me positive. Remember, if exponent is even, it's positive. And 2 to the power of 6 will just give me 64. You could do that into your calculator. Now, let me just show you a few things here. If you have -3 squared is different than having -3 squared like this. Okay. Here, the negative is to the power of 2 as well. So that becomes +9. But here the negative is not affected by the exponent, so it stays negative. Only the 3 has to the power is to the power of 2, so that gives you -9. So make sure you don't confuse these two things right here. All right. Here, what you do in this situation here, you're multiplying. So you have a normal 2 times 5. That's just a normal 2 times 5, which is 10. M to the 3 times M to the 6. You add the exponent, that gives you M to the 9. All right. Now let's go here. What's the first thing we should do here? We should put this exponent into here and to there. So again, if I write an x and I don't write anything, as I said, anything that you see, a 3 has a 1 on top. If you see a y, it has a 1 on top. So make sure you're multiplying that 2 to the ones that are here. So that becomes 2 squared x squared times, and that's just normal 2x, which gives me, that has a 1, of course, as we said, and this has a 1. So 2 squared times 2 to the 1 gives me 2 to the 3. And x squared times x to the 1 gives me x to the 3 as well, which gives me 8x cubed, because 2 to the power of 3 is 8. Now, before I move on to the next slide, let me know if you want me to go over any of the stuff that we just done. You make sure you understand that. Repeat 8, okay? Yeah. So 8, just multiplying, So this is a whole number times a whole number. This is 2 times 5. That has nothing to do with the exponents, because the only thing that has exponents is the m and the m here. So 2 times 5 is just 10. And m to the power of 3 times m to the power of 6 is just m to the 9. That's all to it. Now it gets a little bit, it's not really challenging. I wouldn't say challenging, but if you want to do this here, work on top first. So if you're working on top, all you need to do, just you're multiplying. That means multiplying. So you're going to get c to the 13 because you're adding the exponents here. And here you're getting c to the 6 because you're adding the exponents here. Now this becomes dividing. this to the 13 divided by this to the 6, 13 minus 6 is, gives you c to the 7. Or you go c to the 6 goes into itself once, it goes into c to the 13, c to the 7 times. Because as I said, you're going to be doing this most of the time when you're dealing with, so know how to maneuver. You know, some of you who are in grade 10, you realize, you know, you have to know it both ways, because when you did the exponent section, you need to know it both ways. All right, now here, and that's where this comes handy. Okay, so now we have this. What do? We reduce, okay? And when you're reducing variables with exponents, always the variable with the lowest exponent goes into itself once. Okay, this goes into itself once. It goes into x to the 7, x to the 4 times. So therefore, we're left with 1 on top and x to the 4 on the bottom. Now, let me see if all of you understood how I did this. So just write 1 if you understood it. Yeah. So if we have 4x to the 3, y to the 9 over 16, x to the 10, y to the 5. Yeah. Now pay close attention to what I'm going to say right now. When we have fractions, we reduce fractions. So that's what we do. We go for reducing. To reduce, you have to look at different things here. You have to look at the 4 and 16, the x and the here on top and bottom, and the y on top on the bottom. The 4 and 16, they have nothing to do with the exponent rules, because none of them they have exponent of 1, but that we don't care about. So here they don't have exponents, but we know if we're reducing fractions, the 4 and 16, we could reduce them normally, like what we did in fractions in grade 5, 6, and 7. We go 4 goes into itself once and goes into 16 4 times. So just basically reducing fractions. If you have 3 over 9, we go 3 goes into itself once, it goes into 9 3 times. So that's 1 over 3. If we have 6 over 9, we go 3 goes into 6 twice, goes into 9 3 times. So that gives me 2/3. So the 4 and 16 here, the way we're doing it the same way as here. All right. Yeah. And or so we go back to that question right here. So as far as the 4 and 16 are concerned, all we're doing is reducing fractions normally. But now we go here. When we have variables, we have a variable on top, a variable on the bottom. The variable with the lowest exponent is x to the 3, because 3 is less than 10. So what we're doing, basically, we're dividing this by x to the 3. When you divide something by itself, you get 1. And if you divide this by x to the 3, you get x to the 7, because when you're dividing, you're minusing the exponents. The same thing here. You look at the one with the lowest exponent. Is the 9 or the 5 lower? The 5, of course, lower. So you divide both top and bottom by y to the 5. So you divide this by itself, you get 1. But if you divide this by y to the 5, you get y to the 4. And therefore, this gives me what's left, 1 times y to the 4. We just have y to the 4 on top. 4 times 1 is just 4 here, and x to the 7 on the bottom. That's basically what it means. And Phoebe, this is really what you have to be looking at, like, because once you start doing negative exponents, if you don't understand this basics right here, then you get lost. And that's what happened. You know, I was talking to a few teachers, you know, absorbing what's happening with the school system. You know, lots of kids, grade 9, 10, they're really struggling, because when they were doing grade 9 during COVID, the course was done very fast. I wish they did it online and kept the same pace as usual, but they did it really fast. Lots of kids, they cannot keep up with that pace, you know, or that pace. So now, before I move on, do you understand? This one I just did, the last one I did. Marianne. Phoebe. Nigar. Okay, so this here is very key to reducing fractions when you have variables with exponents. This is key for you. Yeah. So now we're gonna go to this one right here. This one is exactly like this one. So what we do, we multiply the top. The base is -5, so you keep it as -5. You add the 31 and 9, you get 40. And we have that on the bottom as well. So this divided by this, what does it give you? Everybody write the answer really quick. What this divided by this, what does it give you? If you divide anything by itself, it's always 1. It doesn't matter what that thing is. It could be big, it could be, as long as you're dividing one thing by itself, the answer is always 1. So this here, the top and the bottom are the same. So it's 1. However, if you want to see what happened as well, you know, for me, I just cross them out and say 1, 1 because they're dividing something by itself. But also if you want to go to what's happening, when you're dividing, you minus the exponent. So 40 minus 40 is 0. And as I said earlier, anything to the power of 0 is always 1. So it doesn't matter, negative, positive, as long as it's inside the brackets and you have 0 on outside, then it's 1. That's the answer. But also you should know that when you're dividing something by itself, you don't even have to go through this step. This divided by itself is 1. Always. Okay. So let me move on. Now here is similar to what I showed you earlier and said it's important to know, you know. The first thing I need to do here is still multiply the tops together. So when you multiply the tops together, can everybody write me what you get? And the bottom, you just keep the same. So what do you have on top? Just write really fast. Here you have to look at 4 times 5, which is 20. And m to the 12 times m cubed, which is m to the 15. So you have to separate things here. It's 4 times 5 first, which is 20, and m to the 12 times m cubed, which is m to the 15. And we still have 10 m to the 6 on the bottom. Now again, when you're reducing, in this situation, you have to reduce. So these are numbers. When you reduce them, let me give you a little thing that a lot of students don't know. So if we have 300 over 900 and you want to reduce them, just know a 0 from the top takes away a 0 from the bottom. Another 0 here takes away that. So basically this becomes 3 over 9, which when you reduce, you get 1 over 3. Okay, so whenever you have zeros like this, just every 0 from top cancels a 0 from the bottom. So you have 2 zeros, they cancel the 2 zeros on the bottom. Yeah. But you cannot do it if it was like this, you know, 30 over 909. Now you cannot do that anymore. You cannot say this 0 cancels this 0. The 0 has to be at the end to be able to do what I've shown you here. So here, when you're reducing, this 0 cancels this 0. So you have 2 over 1, which is 2 on top. And then m to the 15 over m to the 6. M to the 6 goes into itself once because the 6 is lower exponent. And then m to the 6 goes into m to the 15. M to the 9 times. So the answer is 2m to the 9. As I explained to you earlier, if you have a negative number to the even exponent, and it's inside the brackets, it gives you 4 positive. But here, the exponent only affects the number 2, but it doesn't affect the negative. So the negative stays a negative, and the 2 becomes 4. How about here? Here, it's a bit more challenging now. Okay, so let me just, what I'm going to do, I'm going to move this question right here. to the top. So here, what's inside here is a bit different every time. So this is a to the 5, a squared, a to the 6. So what we need to do here, we need to put the exponent inside in each bracket. Okay. So what does that give me? That gives me 4 to the power of 3. And as I was saying earlier, you know, that 4 has a 1 on top. So you have to multiply the exponents, not multiply the 3 into the 4. It's a common mistake that students do. Remember not to do it. So now 4 to the 3, a to the 15 times 4 to the 2, a to the 12, all over 4 cubed, a to the 6, which gives me 4 to the 5, because that's 4 to the 3 times 4 squared, and a to the 27, all over 4 cubed, a to the 6. Now, if you look at these here, this you have to reduce them by using the exponent rules, because here these didn't have exponents on them. That's why I told you to reduce them the old way. But here the 4 and the 4, they have exponents. So 4 to the 3 goes into itself once, 4 to the 3 goes into 4 to the 5, 4 squared times, a to the 6 goes into itself once, it goes into a to the 27, a to the 21 times. So you divided this by a to the 6, divided this by a to the 6, divided this by 4 to the 3, divided this by 4 to the 3. And the final answer here is 16 a to the 21. Now let me know how you're doing with this question. I will repeat it right here. So don't worry if you didn't get it that well, then it will be repeated here as well. Now with this one right here, here we're just gonna raise everything to the exponent. So this has a 1. And the negative, because this is an even exponent, it becomes positive. Okay, so this negative here, because this is an even exponent, it becomes positive. And 2 to the power of 2 gives me 4. X to the 8. So I'm doing this a little bit faster. Negative to the power of 4 just becomes positive 1. This is negative 1, so it becomes positive 1. X squared becomes x to the 8. And this becomes 3 to the power of 3, which if you want, we could just write it right away, is 27. And x has a 1 on top, so that becomes x to the 3. Now, the 4 and the 27, here they are whole numbers. We could reduce them if we can together, but they don't reduce. 4 doesn't go into 27, 2 goes into 4, it doesn't go into 27, so you have to keep them this way. So now we have 4 over 27. This will give me x to the 16 on top, and this is x cubed on the bottom. Now x cubed goes into itself once, it goes into x to the 16, x to the 13 times. And therefore the final answer is 4 over 27 x to the 13. So you could write it like this, x to the 13, or you could write it by the 4. This, both of them mean the same thing. So now I'm going to go a little bit more into negative exponents and all of that. So try to do these before I move on to the next stuff. So up to 4, I want you to do yourselves, and then 5 and 6, you don't have to worry about it. I'm going to go over them. So you have 5 minutes. Okay, I think now I'm going to go over stuff. So this here is x to the negative 14, but always express exponents in positive, okay? So positive exponents. And therefore you have to change this to 1 over x to the 14th as we talked to you earlier. Now this here give you x to the -5, and that will be 1 over x to the 5. This here will be -6. First of all, you multiply these two inside BEDMAS squared. And when the exponent is even, the negative becomes positive, and 6 squared is 6 times 6, which is 36. Now here, who get this answer, or at least that part? Who got that? Because remember, like, you still have to remember the first lesson we did, which is integers. When you're subtracting, when you're dividing here, you subtract the fraction, so that becomes the exponent, sorry, that becomes -15 minus -10. And I said, whenever you have two negatives besides one another like this, this becomes -15 plus 10, which is -5. And then you make the exponent positive by flipping it. Now, this one here, keep the -3 the same way. So that becomes -3. Now, when you're dividing, you subtract. And when you're multiplying, you add. So what you have here, as far as the exponents are concerned, if you want to see it in slow motion, is -6 minus -8, because you're dividing, you minus the exponents, plus, because you're multiplying, you add that exponent. Of course, me, I don't like the integers written like this. So for me, this becomes -3 to the power of -6 plus 8 minus 2, because that is two negatives make it positive, and this makes it negative, which gives me -3 to the power of 0, and anything to the power of 0 gives me 1. So that's how we answer this one. And after that, we're going to go through these here. Anybody wants me to explain any of these again before I move on to this? Yes, please, where? Which, the fourth. So the fourth, when you're dividing, you minus the exponents. These are the exponents. So we go -6 minus -8, and then we multiplying, we add the exponent, so we go plus -2. And then just rewrite these. I don't like this, the way this sign's written like that. Negative and negative is positive, and positive and negative is negative. And then when we add -6 plus 8 minus 2, it gives me 0. So that becomes -3 to the power of 0, which gives me 1. -6 plus 8 is is 2. 2 minus 2 is 0. Okay, so you're good then. Now it's here. Maybe I should have given a little bit of space. So I'm just going to rewrite 6 a bit here. Yeah. So now we're going to go to this. This is exponents and fractions all over it. So the first thing I need to do here, because the exponent is negative, remember that rule, if you go back to that page, if we negative exponent and everything, fraction inside the brackets with the negative exponent, you flip that fraction, you make it 3/2 instead, and you make the exponent positive, times 4/9. Which gives me, when you have an exponent outside of a fraction, brackets, and inside you have a fraction, you do 3 squared and you do 2 squared. 3 squared is 9, 2 squared is 4, times 4/9. When you multiply a fraction by its reciprocal, so this is a fraction and this is reciprocal. Reciprocal means when the fraction is flipped upside down, you always get 1. So a fraction times its reciprocal is 1. But also you could just go, the 4 goes into itself once, goes into itself once. 9 goes into itself once, it goes into itself once. So 1/1, that's what the answer is. So that's 1. Number 6. Number 6, we're going to go with this. We really got to work what's inside those brackets first. We're not going to deal with the exponent yet. This is 1/4 minus 1/16 because 4 squared is 16. And then the common denominator here is 16. 16 divided by 4 is 4 times 1 is 4. Minus 16 divided by 16 is 1 times 1 is 1 to the power of -2. So if you like doing it, multiply this by 4, multiply this by 4. That's how I got that. That's how you like doing it. So now this here, 4 minus 1 is 3. And this is 16 on the bottom to the -2. Which gives me, I'm just going to do a little line here so we know. It gives me 16/3 squared because we always want to make the exponent positive by flipping the fraction. 3 squared is 9, but 16 squared, you could just use the calculator to find that. $256. So the answer is 256/9. Now, let me know before I move on to more questions, if you're good with that. Okay. Good. Got. So I'm just gonna move on. And I'm gonna kick in a few more questions. I hope everybody is doing these. They're a bit challenging, some of them, like this one is a bit challenging. This one is easy. This one, yeah, not bad. Once you do the first thing, then you'll be okay. Okay, Nigar. So just in math, always you try. You have tools, you try. You don't look at them and say, oh, I know what the answer is. Okay. So, Marianne, apply the rules that you know. Don't look for the rules that you don't know, because there's no rule that about adding things with exponents. There's no rule. You cannot do anything. Of course, you know, when you grade 9 and 10, you think, what is the rule? You know, I've been down that path, you know. Do we have rules when we're adding and subtracting? No, we don't, unfortunately. Now, here, what's the first thing we did about negative exponents? I said, when you have negative exponents, we don't like negative exponents. So all you need to do, just bring that -2 to the top. So it becomes -2 to the power of 3 plus 2 to the power of 2. Problem solved. Is this clear? So let me know if that's clear. Okay, excellent. So -2 cubed is, because the exponent is odd, is going to be negative, and 2 cubed is 8 plus 2 squared is 4. And -8 plus 4 is -4. So something that looks really hard, if you bring it down to basic, it becomes this, which is a lot easier, and then this. How about this? What did everybody get for this one? Just write down what you got for this one. I'm waiting everybody, I'm expecting everybody to write the answer. So let's worry about the numbers first here. Phoebe, you gotta write some answers. So let's focus on some of the things. The first thing we have to focus on the 45, the 9, and the 3. That's just normal. 45 divided by 9 is 5 times 3 is 15. So you have 15. And now you focus on the x's. -9 minus -4, that becomes -9 plus 4. And then multiplying, so you add the 5. And therefore, that's -5 plus 5, which is 0. So that becomes x to the 0. That's definitely 15. Because x to the 0, x to the power of 0 is 1. So 15 times 1 is 15. Yeah. This is not 15x to the 0 like this, because if it was like this, then the whole thing becomes 1. But that's 15 by itself, and x to the 0 by itself. So x to the 0 gives me 1. 15 times 1 is 15. So whoever got 15, arrive into it this way, you did marvelous. Okay, Muhammad bin Hassan. You got it, or you want me to slow down a little bit more? Oh, okay. No worries. Good job, buddy. Now, this one is a bit more challenging. It's not the first step that's challenging, but after that, a lot of people get stuck on it. Beautiful, Nigar. Good, good, good. 4 to the -1 here, you have to deal with each one separately. So 4 to the -1, I have to write it as 1 over 4 and make the exponent positive. But since it's to the power of 1, I'm not even going to bother writing it. And this is 4 to the 0. 4 to the power of 0 is 1. So we have 4 over like a fraction within a fraction. So we have too many fractions here. Let's leave the 4 the way it is. Now we know this is the same as 1 over 1 right here. So we're going to do a common denominator here, which is the 4. So that becomes 1, and you have to multiply this by 4 and multiply this by 4 to have a common denominator. So that becomes plus 4 right here, which gives you 4 over 5 over 4. Okay. In my fractions course that I'm starting next Sunday, I always tell students, fractions mean dividing. So if you have 3 over 4, that's a fraction, but also it means 3 divided by 4. Here, this is your division sign right here. That's the main fraction. So this is dividing. This means dividing. If it's dividing, can I go? I don't like dividing. We always change dividing by switch to multiplication, the division, flip 4 over 5, which gives me, when you multiply a whole number to a fraction, if you could reduce this way, fine. If you can, just multiply this 4, the whole number, just to the top of the fraction, which gives you 16 over 5. I hope you're learning, like when you watch the video, you kind of reinforcing what you've seen so far, and now it's you could rewind it and do all of that and be able to pay more attention. Okay, but just focus in this class. If you come out from this class understanding 75% what I'm explaining, then you'll do really well in grade 11 and 12, because this is the basic algebra stuff that you need to know for that, these 2 grades, and you do well in math and win scholarships and all of that stuff. Any questions before we let you go today? So here is another class. We just finished it, good group of students. Again, lots of students struggle with negative exponents and exponents in general. Once we start doing negative exponents, and then we go back and forth from reducing fractions, variables with exponents, to should we switch everything to positive first? There are different methods when it comes to this kind of chapter. Every teacher uses a different method. Mine, I don't like negative exponents, so I try to flip and all of that and change everything to positive exponent. Sometimes you cannot do that right away. You have to deal with negative exponents till the right time. When the right time comes, you change the negative to positive exponents by, if the negative exponent variable is on the bottom, just flip it to the top and it becomes positive, and vice versa. Okay, so this is how this chapter works. Again, thanks for those students who were part of this, and also thank you for watching this video. Your support goes a long way. Don't forget to hit that like button, subscribe to my channel. We upload every week, a couple of videos at least. So again, thanks for watching. Till next time, bye-bye.